I guess we're live. Hi, hello, good morning, good afternoon, good evening to whichever part of the world you're joining from. How are you all doing? Um, if you're joining us live or later on, I hope you're doing great. If you can watch me live, I would really appreciate if you can put a comment that I can know that yes, there are people watching across platforms. I'm Mudit from DeFi. I think most of you would know about DeFi. It's a global community of data science where people can educate and build AI for all. We started 2 years ago with the idea of democratizing AI education, and so far we have impacted over 100k plus people from 150 plus countries. These live sessions are opportunities where we bring together folks like Ladley and many other contributors who are making an impact in the industry as a professional, and then they are coming on board to teach for free and live. So, as a learner, you get to get hands on skills over the weekends live by learning from these AI leaders. Now, talking about Ladle, I think most of us would know him well because he has taken several sessions on DeFi so far. But I would still do a brief intro for those who do not know him. And then I would definitely hand it over to him because he can do it better. He can introduce the topic better and himself, of course. So Ladle is a senior data science manager at Genpact, Hyderabad. He looks after the Hyderabad side for data science. He's also the founder of Unlearning Relearning Community, which is run with the idea of spreading high quality tech education to rural and small town students in India. Apart from that, he is someone who's absolutely passionate about climate change. He comes from the community and he has worked on various domains like ML ops, data software engineering, data science, machine learning, big data, and more. Uh, he is also a passionate educator, which is why he proactively contributes to DeFi. He puts in the effort and time for enabling this high quality education for you all. So on today's date, he'll be talking about it's not just a talk; it's a proper session where you get to learn, you get introduced, and then you get to know how to implement MLflow. Now, what is MLflow? If you're somebody who is into data science, you may know how tricky it is to take ML Jupyter notebooks to production. Most of the projects would actually fail there, and even if you do it, managing end-to-end machine learning cycles can be a hassle. That's when something like a powerful tool like MLflow can be an important tool in your arsenal. Now, in this session, we'll be focusing upon MLflow itself. Now, without any further ado, let me quickly loop in Ladle for him to lead the session. Hi, Ladle, how are you?
Hey, hey, Mudit. Thank you. Yeah, I'm good. How are you?
I'm good. I'm good. Thank you so
Can
much
you hear me?
for being on DeFi again. Yep, sorry.
No problem. Yeah, it's an honor to be a part of a global community.
No, no,
I
it's
think there is a
yeah,
lag.
it's a mutual pleasure. Yeah, I think there's definitely lag. Let me do
Yeah,
this. I'm handing over the stage to you so that you can take it over, and can we can dive right
yeah,
into the session. Towards the end, towards the end, we'll be having the Q&A. So if you have any questions, put them in the comment section, and we'll curate them and we'll try to pick them up towards the end. So over to you, Ladle.
thanks, Mudit. Thank you, D5, for giving me again, once again, the opportunity to share my experience. Okay, as Mudit told me about me, so my name is Ladle Patel. I have a nearly 10 years, more than 10 years experience. I work for Genpact as a senior manager. So I have also co-founded a community called Unlearning Relearning along with my wife. So the vision of the community is simple. So we go to rural areas, colleges, schools, and help students to spread awareness about the climate change, help them in building their profiles, help them in understanding the right from English to the maths in a right way. So I also speak at Hyderabad Community Python Group. So this is what about me. Okay, let's get into this session. Is more of a hands-on. I'll just give. If you don't know machine learning, if you don't know what is API, so it will be a little difficult for you guys to understand. I assume that you have a understanding of machine learning at least to a basic level, not to like an expert level. So I'll start. So here we go. So I have a notebook. This is my VS Code. Before getting to, let's understand the data first. Let's do one thing. So what we'll do is we'll build a simple linear regression model on this data set, and then we'll see what are the challenges we have in converting this Jupyter notebook before we take it into production. What are the challenges we face, and then we'll take some of those challenges, and then see how MLflow can help us in resolving those production issues without any manual effort. So this is the data set. This was the those who don't know Kaggle. Kaggle is a platform. Kaggle is a Google company where companies they come and host their challenges. It's a data science. It's a competitive platform for data science, like any other platforms like HackerRank, Geeks for Geeks, or Lead Code. Competitive platform for coding, right? Those are the competitive. This is a competitive platform for data scientists. So here, people around the globe, data scientists around the globe, they contribute, and then they participate in the various competitions. So there was one competition. It happened 8 months ago. So the objective is very simple. I talk a lot about climate change, educate a lot about climate change, spread the awareness about the climate change. So this data set is in line with what I generally speak. So it's basically the objective is to predict the energy usage of a building. So you have a building, you just have to in simple terms, how much electricity bill you get end of the month, right? So it's based on the your usage. So objective is to forecast or predict roughly what will be the average, what will be the building usage, right? Energy usage for a particular building. So we don't build. So this session is not for building a super awesome, super accurate machine learning model. The idea is to take some features. Here the focus is the metrics or the KPI is not to evaluate or how good or how best fit our model is. So the objective is to just to have an end-to-end flow, and then see how we can deploy in a production in no time. So the data has the various features. So the target is very simple. It's a regression model. It's a continuous model. If you don't know machine learning, so regression model is one of the supervised machine learning models. There are various categories in machine learning. So supervised, unsupervised, reinforcement learning. So linear regression is one of the techniques in a supervised machine learning technique. So here the objective is to predict the continuous values. So you have been given the data set, all of these year factor, when the building is built, the floor area, when the building is built, and so the various other factors, right? And then we have to forecast or the predict site energy usage intensity. It's basically the amount of heat and electricity consumed by a building, so that you get it in a bill, right? So this is what the objective is. So we have a data set, and then so on and so forth. So what we'll do is we'll take some features, maybe few features, and then we'll train a model, and then we score that model, and then from there, imagine a situation where you someone ask, or your client or your boss asks you to put that model what you build into production, and then how you go through from Jupyter notebook. Imagine you are a data scientist. To make your model into production, you need a solid data engineering skills, you need a solid Linux skills. There are many other skills. You require a bunch of team members, DevOps engineers, MLOps engineers. You require many more folks to make a simple Jupyter notebook into the form which can be deployed in production. You have to follow various guidelines, and then we'll see how ML tools like MLflow can help us in resolving those issues. So let's get into the notebook. So this is the notebook. What I'm doing is nothing. This is same notebook. I mean, if you are building a machine learning model, so you will know what I'm talking about. So it's a simple Jupyter notebook. You import required libraries. I've used Elasticnet. Elasticnet is a combination of Lasso and Ridge. So it's like a regression model, linear regression, like a linear regression model. So I've imported the libraries, required libraries. I'll just read the data set. This is where my data set is residing. I've kept it here itself. I'll read the data set. And then to weave the data, few records, I can use head. So although it has various columns, right, various columns, and this is our prediction. This is using this all these data set, right? So we have to predict what is the energy usage, right? So this is energy usage for a particular building. This is what we have to focus. This is the continuous value. So you have a decimals. This is a continuous value. So you use linear regression, and then for that we have been given various data source. I've chosen few. Floor area is the spread of the area. So obviously, the bigger the building, the consumption is more. Year built, the older the building, the technology is older. So obviously, it takes time. And then elevation, the height, right? So the more the height of the building, so obviously you consume more energy. So I've chosen few. The very, I mean, I could have chosen the categorical features. I could have chosen various other factors, but to make it very simple, so that I don't get into a trouble of deriving more features, demifying those features and all. So I use simple plain features. So I've selected out of these columns. If I want to see, how many rows and how many columns I have, I can just see how many rows and how many columns I have. So it is a very simple. These many rows I have, and then 64 columns I have, 7,500. Mm, yeah, 75,757 are the rows, and then 64 are the columns. So this is the data set I have. Out of these, I've chosen only few, three columns input I have chosen, and then this is the output. So yeah, same goes. The data has some null values. If you see some of these columns like null values, so NAs, so something like this, not a number. So obviously we cannot train a machine learning model using NAs. So we have to drop them or fill them or replace them with some other values. So I've just dropped them so that our purpose is to not to build a super awesome model. Our objective is to simply see we can have a model, a simple model or not. So yeah, I was able to drop, and then obviously there are few records which got dropped. Yeah, so if you see here there are 7573, so around few records got dropped. So yeah, I've taken a variable which y is what I have to predict, and then I've dropped y from here, and I'm doing the train and test split. If you know machine learning, what is machine learning, you understand this. I use training data set to train a model, to train the model parameters, to get the models, and then you use the test data to inference or the predict how good is your model performance on the test data set. This is my model. I've divided the data set into train and test, um, and then I have some parameters, some hyperparameters which elasticnet uses. I've used those, and then this is where I've used the elasticnet machine learning model. So which is, as I told, which is a combination of lasso regression and then ridge regression, which will help us in doing feature selection and feature elimination techniques. So it's like a little advanced feature of machine learning, linear regression, traditional linear regression model. So although I don't require, I've just used it because I have only three features. So it is not. I could have used simple integration, but I have used so that I get some more parameters to tune. So this is where the model training happens. The fit function is where the model training happens. So basically, what you are doing is this: you are giving a data set, right? If you see this, if you see this data frame, so what you are doing is essentially you're training a model. You're giving three as an input, and then telling it build is this, and then elevation is this, build consumption. This is the bill which was there, for a particular building. And if this is the area, and this is here house built, and these are the inputs, and this is the output. Our objective is, if someone gives us these things, we have to focus to predict what will be the price, right? What will the price? If someone asks, if someone gives me, let for our house, the where I'm staying in, if I give this information to the model, model should automatically predict what will be the energy usage for a particular month, or whichever the way I want to forecast, right? I want to forecast for a quarter or month. I want to forecast what will be my energy usage. So this is what the output is. So I am giving here, if you see here, this is where X train contains. So train X contains the inputs, and Y contains this output for corresponding inputs for my output. I'm using this. If you know machine how to train and all, it will be a little difficult, but I believe most of you know. So this is where my training happens. The model is trained, and then I use different techniques. There are various ways to evaluate machine learning models. So I've used some of the metrics: root mean square error, root mean absolute error, and then R squared is to check the goodness, fitness, how good is how good the model is fitted on the existing data set. So, and then I use, I've trained the model. I've trained the model. Everything is fine. I pass the test data set to evaluate my model, right? So I pass the test data set, and then I get the predictions. So this is my predictions, and then I have all my metrics. So the lesser the metrics, root mean square, RMSE. So the lesser the metrics, the near the zero, the better the model is. So and so on and so forth. So the model is really it is really not a good model, but because R squared is very far, so R squared should be near to 1. So yeah, so the model is really not good, but yeah, so that is not the objective, because I have used simple few features and I have not used any feature engineering. I'm not used any advanced modeling techniques. I'm not done any of the EDA, explorative data analysis, to the model. The objective is to not to build a super awesome model. But what I'm trying to say is, imagine you have built this model, and then everything looks fine. So this simple code, and obviously, so there will be some more extra code will be there in a Jupyter notebook when you join data scientist, or if you're a data scientist, already data scientist, you will do some more feature engineering, you'll do some more feature scaling, and some sort of normalization. You do plotting, and then you remove outliers, you impute outliers, so you impute, and then null values, you combine features. So there are many things you do, you play around to come up with a better model. Now the thing is, imagine the situation where you have built a super awesome model, which is sitting in your laptop or even your server, but it is not in a usable format. Unless it is deployed in production, it is not in a usable format. So now that's where the challenges are. That's where I'll show you what I'm trying to say. So this was, before I go here, the same on the same topic, on the MLflow topic. I gave I gave a talk at the Hyderabad conference, Python community group. So 4 years ago. So the MLflow it was actually in a beta version at that time. So I gave a talk on the same topic. Most of the things remain same, except there are integration with some other tools and a new functionalities being added. But it was not even at that time, it was not even production ready. But I knew the power of this MLflow before what I'm talking about right now. We use MLflow. We are one of the, I mean, as a Genpact, as a company, also we use MLflow. We are one of the users of MLflow. We've used MLflow in some of the companies, but I knew the potential of this MLflow 4 years ago itself. I have the same presentation. Little bit, some of the concepts are changed, but what I'm trying to say here is, this is the same presentation I have used 4 years ago. If you see this PDF document, I'll just show you the same thing. So this was survey conducted by Databricks. Databricks is a company. They are the core members, or the core members who developed MLflow. Of course, it's a open source framework. There are community members who are also part of the contribution community of MLflow. But when they did a survey, right, where are you in machine learning journey? So how many models you have in production? So 10 plus models and production. Said the response what you see here, just researching, working on first model. If you see the majority is here itself. So now that they are in a span of 4 years, I mean, it is not even balanced, right? It is not even close to 50%. Maybe it got increased to 13%, or maybe little more increase. But in reality, I have seen what I know as an industry. Most of the model, they sit in the server or in the form of Jupyter notebook itself. The reason, there are various reasons. There could be management issue, there could be any political issues, there could be any other issues, there could be lag of the skills, there is no potential use of that, there could be many factors. But one of the core reason is the lack of the skills, which basically the complexity which is involved in making your Jupyter notebook to production. So still organizations are figuring out, they still don't know the power of tools like MLflow, Qflow. There are various other tools which you can use, leverage to automate your machine learning pipelines easier. So this, I think you already know most of things. Simple machine learning pipeline includes the typical machine learning. You have data, you do typical data analytics, you do feature engineering, feature selection, and you build a model. And then this is a regular machine learning pipeline which I presented 4 years ago. ML in production looks like this. You have to automate many stuff. You can't, if you are a car manufacturer, you can't do handcrafted, right? If you are producing hundreds of car per day, so you need a robot, right? You need an automated system. You can't do all of these handcrafted, right? So you need a system which is automated, which is seamless, which can be easily converted from Jupyter notebook to production. So you need an end-to-end system. That's where MLflow comes into picture. There are a few tweets, and this was one of my favorite tweet. It was again 4 years ago. Somebody developed a machine learning model in 3 weeks, but they were not able to deploy this part of nearly 1 year. And because of the many reasons. One of the reason is the skills, and then converting this notebook into production. Client, there are many other factors, but the core reason is, again, the challenges which you face as a software engineering skills. You need security skills, you need networking skills, and then you need a production skills, many other skills you require to deploy a machine learning model. So this is again a research versus production environment. You obviously, the one of the factors is, you in a Jupyter notebook, you have a simple data set. You don't require any scaling. But when you go to production, so you require a scaling environment, right? So and then there are other factors. I don't want to spend time here. This is the Google paper, a Google research paper. So if you see the ML code, ML is just a small piece. And I'm sure if you are reading, or if you're part of any ML ops, or if you're part of any DevOps, or anywhere machine learning team, right? So you must have seen this image. So ML code this is from the hidden technical debts of making machine learning model in production. Technical debts. If you just type a Google, it's a Google paper. So this image is copied from Google. So if you see, the ML code is a small world, and there are a lot of other things which are around that ML code if you are making your model into production. So does MLflow help in all of those? But not all. But yes, it can rescue in various ways. So again, this is the motivation. So simple ML, simple libraries like scikit-learn won't help you to make into production. So there are various other companies and all. They commented that it is very difficult to take a notebook code into production. And then we have faced in a various ways. Everything works fine in the laptop, but the same code doesn't work in production. And we'll see how to overcome with these issues. These are the few motivation behind this project. So let's get into what is MLflow. Yeah. So before we go into, again, one more thing, the one of the biggest challenge what we have seen is so let's say you developed a model using scikit-learn, but client uses a Spark. How do I convert a model which is written in scikit-learn into Apache Spark? So Apache Spark is inferencing. During inferencing, let's say you get terabytes of data or requests from millions of requests from Kafka, and then you want to use something like a Spark streaming, Spark ML, and you want to have a Spark model, but you trained your model using scikit-learn. So unless you know the easiest way, I mean, the rescue for this is you convert. I mean, I have involved in various projects in my current organization, also in previous organization, where we had to rewrite the entire code of scikit-learn into the form which Spark understands, because both of them understand totally different. So imagine you built a model using scikit-learn, you put months of effort, and then suddenly client says that client wants the model in production, which is in the form of Apache Spark. So that's where the trouble comes. So you need a skills who are expert in Apache Spark to write that or to convert that. Or maybe you wrote a code which is written in R, but client says client has the environment of Python, or during inferencing time or the prediction time, the environment is in Python, or vice versa. So that's where, or you wrote a code in TensorFlow, but client who uses traditional software, traditional R or scikit-learn. So how do you convert your TensorFlow model to scikit-learn? So there are tools. I mean, you can there are formats, but at the same time you need the scalability, you need the compatibility. That's where these tools like MLflow can help you. So it's a single platform which will help you to scale your model in a easier manner. So I'll show you some of the benefits. I'll show you hands-on. We'll go in detail of the. Let me just show you what I'm talking about. So if you see, this is the official document of MLflow. So basically, it has various modules, or I will say I'll just Databricks. Yeah, I think this is where I have. So MLflow is developed by majorly it is like a Spark. Apache Spark is majorly contributed by Databricks. So and then MLflow again same is developed by Databricks itself. I mean, the major contribution. Of course, there are other community members also, good developers. They contributed to MLflow. Same to the Spark, but majorly driven by Databricks. So again, this MLflow was their internal project, and then they made it open source. Similarly, Meta has their own framework similar to MLflow. Google has their own framework. Uber has their own framework similar to MLflow. And then companies who are using this machine learning in production, they obviously need to have some of these frameworks internally. They have been using this frameworks similar to this internally, but it was not open source. But for us, companies like us, so they have made it open source for the community, right? So they made it open source so that everybody can use. So it has various functionalities. Tracking is one of the favorite functionality which we use. And then you have a model registry, and then projects, and then models. These are the four things they have very famous. So earlier they started with MLflow tracking, and the MLflow projects and the MLflow models. So we'll talk about what exactly MLflow tracking is all about. We'll talk about MLflow projects and then MLflow models. So it is very simple. You imagine a situation where you are asked to you write a code. Obviously we have a GitHub version control and all, but you want to know all the hyperparameter which you used. You want to know the code, you want to know the metrics, you want to know what data went in to the model, but at the same time you want to also have a REST API. There are many more things you want to have, unless you write your manual code, right, to do these things. You won't be able to achieve those. Imagine a model you trained maybe 8 months ago, and then you want to know what all the model parameters which you used. It becomes very difficult, right? So what are the model parameters, what are the hyperparameters you used, what if you want to use that model which was developed 8 months ago, or you want to compare the model which was developed 8 months ago with now. I want to compare the metrics, not the code. I'm talking about the metrics, or which model is better, the model which is developed 8 months ago or the 2 days. You want to compare on various factors. Now tracking those things are very difficult. Now you want to have an API, right? API to serve. So all of those things becomes easier when you use MLflow. So I'll just quickly show you what I'm trying to say. So how do I convert this notebook, which is plain notebook. uh, I'll just take a pause. This is the notebook. I'll just take a pause, and then yeah. So I've used this metrics. I'll just show you what how it differs from only few lines of code. Only few lines of code. How much it can save you in production. What all things it can do in production. I'll show you. So this code remains the same, except I've added few. You have to have install MLflow. It is very easy. Pip install MLflow. That's all. So it is similar to like a scikit-learn. So all you have to do is install library in your environment, and then I'm reading the data set. It is same as this. I'm just reading the data set. So it is same as this. I'm doing the same thing what I did here in this notebook. Okay, so I'm selecting few features. Nothing difference. It remains same. Um, I'm just dropping some columns. So sorry, some. I've selected few rows, and I'm dropping NAs, not a number values. I'm splitting the data set into train and test, and then yep. So I have the model parameters. Sorry, helper parameters. So this is where uh, all you have to do is include line number. This is line number 1, 2, 3, 4, 5, 6, 7, 8. These things, if you want, you can include 7 or 8 lines of code. I'll show you what these 7 or 8 lines can do, and how you can. This remains same. It was there before also. This remains same. This remains same. These things remain same. Only thing is you have to start this MLflow and include whatever you want, right? This only these 4 5 lines of code or 7 8 lines of code can save you big time in production, can do miracles which takes days or months to rewrite the notebook which you have written. So it can save you. It can be a savior to directly you can run this notebook whatever you built in production using only few lines of code. So I'll just run this. So I'll show you what all things this can do. This once you do this, that's all. What you have to do is I'll just go to the official document till the time. This is the official document of MLflow. All how do you do? You just have do pip install, and then that's all. So what happens is there is an UI Spark MLflow UI. This is for tracking all your activities. So I already started that. I'll show you where I started. So if you see here, I've already started as MLflow UI. Okay, this is where MLflow UI is already working running. So you can also just by typing a simple command MLflow UI. So you can start. This model is running. I'll show you what all how it is stored. So I've started. Where is it? It is running at this location. So it runs at 5,000 port number 5,000. So this is the one which we ran now 1 minute ago. So using this model, what it has done, those commands, right? Only few lines. What that code has done is, so it basically created the entire pipeline. Entire pipeline it has created. What exactly mean by that is it has created the. If you want to take your code into production, so you need to follow a particular structure, you need to follow a particular framework, right? So to what are the requirements, what are the version controls, uh, what are the requirements you have, requirement in terms of requirement.txt. If you see here, so it is using MLflow, it's using scikit-learn, all the libraries it has automatically exported based on the environment what I'm doing. It has already exported, and it has created a YAML file. It has created a model pickle file. It has saved the model file in the form of pickle file, and then it has created a YAML file. Again, it all the requirement I want, and this is how the structure looks like. This is the basically it has created a project structure. A lot of time, what happens is when you go to production, right? When you are actually developing a machine learning model in production, reproducing, let's say if you developed a model, but someone says that your model is not working according to the requirement. So how do you reproduce that? How do you reproduce that? You should be able to identify the data set, right? So this is where what this piece of code is doing is, sorry, I'm navigating here and there. I'm just logging the parameters. These are the parameters. These are the model parameters. I'm just logging the metrics. I'm just logging the model, saving the model. Using this same model, I can build a API. I can build projects. I can ask someone to run my code, piece of code. They can easily integrate. They can integrate this model in production. They can integrate this model in R. They can integrate this model in Python. They can integrate this model in Spark. They can integrate SageMaker wherever they want. It has created that format. It has created it's like in Java is a platform independent, it can run anywhere, something like that. It is like it has created a model where you can run in wherever the environment you want, in a production, wherever you want. We'll show you with examples. Simple model. What I did is, if you see here, imagine I built the same model yesterday also, similar model. So there are a few other things. Let's say you want to compare the model, these two models. Which model you log everything, right? You basically you are saving everything here in this format. You want to compare which is better, which model is better. Imagine a situation you are keep on running every day, every month you are retraining a model, you are running everything, but you want to choose which model is better. So you want to go based on, let's say, a particular metric. You want to go descending order. You want to choose that model. So imagine you want to choose this model, and then you can go and see what is that model, what version it is. You want to use this model and you want to share this model to a client. All he has to do is he has to just follow this command. How to run this command in production? It runs as without seamlessly. So it is very easy. So I'll show you. You will understand what I'm trying to say. Uh, so the same model, if you see here, I'll show you what. Yesterday, I ran this model. This is the model. This is the model I saved. Everything was fine. So I want to, let's say I want to run this model. I want to build an API. API is application programming interface. Let's say someone, a .NET application or Java application or any front-end application wants to use my predictions, the model predictions. They want to use my model predictions. So the easiest way is to, you can build an API. So if you are a software engineer, you know how much time it takes to build an API. It takes a lot of time to build an API. So I don't have to do anything. I have the model ready. So I don't have to build anything. I don't have to write an API. There are API like Fast.api, Flask, Pyramid, Django. There are various frameworks which you can use to build API. But with MLflow, you don't have to do that. Automatically, this will give you an exposure to API. So I'll show you what I'm trying to say. So yesterday, what happened is, so I built a model. Everything was fine. I'm not running this just to avoid, just to save the time. So what I did is, so I built an API. Everything was fine. I've saved the model. I got the model ID. So all I did is I just ran this command. I just ran this command by just passing this. If you see the model ID, right? This model ID. This is the model ID. I just ran this command. I'll also show you by once I do this, right? I'll also show you what I'm trying to say. This command I ran automatically. What it did is it gave me an API endpoint. It gave me an exposure to API endpoint. So someone who is sitting as some other application, .NET, Java, any other application or front end application, they want to consume our model. I don't have to write an API. Automatically, it will give you predictions. So I have Postman. If you know Postman, you'll understand. It is running at this port, and this is the function which I have. So the model is running. All I have to do is, let me change some of the numbers so that you get what I'm trying to say. Maybe this is becomes 20. Okay, so if you see here, yeah, so you got some different predictions. So what I'm trying to say, earlier what used to happen is, when you develop a simple notebook like this, earlier when I started my journey of data science, right? So what we used to do is, if someone wants to consume our model, we had to go through various hassle, various complex production process to build an API, simple API, even to a simple API. So you don't have to do that. You don't have to reinvent the wheel. You all you have to do is, if you want to build an API, nothing required, only one command. How does that working? Only one command, which this saving a model, right? This saving a model, only this command, one line of the code is exposing you, is giving you various options to build your model. So only using that model, right? Just this command, and this model, the model which you saved, the model is saved at this location. And then all you have to do is just run this command, MLflow model serve, and this is the model path, and then which port you want to run. And that's all. Automatically what it does is, it will create an environment, it will do everything whatever is required to run that environment. From where does this environment takes, how does it works, it install all the libraries automatically, and then start running. So from where does it takes all of these? It takes from this. it takes it takes from, because the moment I did a save, right, save the model, log the model, automatically it creates a structure like this. So using this structure, we were able to build the API, and then that API is again exposed to some other person to consume. This used to take a lot of time earlier, and then in one command it saved one of our feature. The second thing, this comes to the model, right? You serve API. The second thing, what we can use, imagine you saved a model, everything is fine now, but what happens is, imagine you save the model, but your client says that he is using a Spark. Client says that, look, you might have developed a model in your laptop using Python, Pandas, Scikit-learn, whatever the framework, but my production environment is Spark. Or imagine you have a team of data scientists, they are expert in Scikit-learn, but they don't have expert in Apache Spark, or vice versa. So but somehow you built a model using you have, I'm sure you will have various models saved in Scikit-learn in your laptop, but many projects fail because they won't be able to scale it. Apache Spark is a parallel processing framework. Now client, or you want to use Apache Spark, but you don't want to rewrite everything, you want to use the existing model itself. How do you do inferencing? That's where again Spark, that's where MLflow comes into picture. With the same command, with a single command, only this command, the model which you saved, you can use this, you can use in Spark. So I'll show you what I'm trying to say. You use the same model, you use the same thing, and then you can load the model. How do you get these numbers? You can get these numbers from here, right? So the model which just I ran, so this is the model ID, this is the path, right, which I can use, which if you see here, I have used here, in here, if you see here, if you see the command here. So to build an API, I've just given a path. Yeah. So I'll just copy this. I'll show you what I'm trying to say. So this is the path. So in our case, if we want to, this copy, and then change the path. If I want to run a model which is recent one, right? Change the path and run. That's all. So obviously I have to change the port to some other, because that port is already running. So this is how I can run. I'll run after showing end to end, because it takes time to run. It creates an environment. The same command, the file which I can use the same path, right? Same path. If you see here, same path to load in Apache Spark. If you see here in the code, what I'm trying to say here, I use the same similar model, the model path, and then I read the data set. This is the Spark data frame. Everything is Apache Spark, but we have built a model. We have built a model using Pandas. We are importing that model as a Spark function. I'm taking only few records. I've load the, see, this is where the path is. I've used one of the models. Model is built using Python scikit-learn, but I am loading that model in a Spark environment, Apache Spark environment. This is the model. I select again. This is a Spark function, Spark data frame. Spark data frame. If you see here, drop NA. I'll follow the same thing what we did, right? So, and then I'll call this predict function automatically. This is the Spark data frame. I'm calling this on a Spark data frame. Spark data frame. You can also see what type of data it is. So you built it using pandas scikit-learn. Now what you are trying to do is you are importing that model which is built in scikit-learn, and you are putting in Apache Spark. If it is Apache Spark, this data frame is both are different worlds. And then MLflow, the reason why they both are different world, most of the people in research they use scikit-learn, but in most of the people in production, because of the scalability and all, production people use Apache Spark for the batch processing, for the streaming processing. So, but if you got the requirement, all of a sudden you want to scale your model which is written in scikit-learn to Spark. So all you have to do is you have to rewrite the entire code which is written. You have to redo everything, and additionally you require a skill which has a expertise of Apache Spark. With this, you don't need in conversion of that code. You can easily load that in the model, and then you got the predictions here in a batch format. Similarly, imagine a situation you have a R. So you developed a model in Python, but you want to import in R or some other framework. So this is again a similar thing, but it is in pandas. Let's say you developed in some other environment, and then you want to use that in other environment as a batch processing. Instead of API, you want to have a batch processing. You can easily do that. You can load as a function. The model can be loaded as a function, PyModel function, and then you can do a batch predictions of a massive amount of data, right? So this can be a rescuer. So this is the production code. You don't have to do anything. This is a production ready code. This is, and you don't have to, the problem is you don't have to worry with the versioning. You don't have to worry with the with the scaling. You don't have to worry of writing an API. You don't have to worry about the best practices of production code. Of course, there are few things you have to take care of: exception handling. You have to do pre-processing. There are few things which won't change. Best practices of the code and all, you don't have to worry, because to make your simple model in production, this can be a quicker and faster way. And then it can also be scalable. You can also integrate with SageMaker. You can also run on Kubernetes. There are many other things. All you have to do is, imagine you developed everything is perfectly fine. So what you do is you post your code, right? You to post it, you post basically in a GitHub. I'll show you what I'm trying to say here. So you developed a model. I developed a model. This is the format. If you want to have a production ready format which generally you don't give notebook to production or the other developers, right? What you do is you convert into Python format. So it is similar to what we developed. It is same as this. You imagine everything is same, except you log some of the parameters here. The other things you have, all you have to do is follow this structure, this YAML file, and then the ML project file. This structure you have to follow. Now, let's say you develop the code, everything is fine. This is like a Jupyter notebook itself. There is no change. Now you want to run this in a production. You want to ask a DevOps engineer to run your code in production. You don't have to worry about what version of the development environment has, what version of the production environment has. All you have to do to tell a guy who is actually a DevOps engineer or a Linux admin. So all you have to do is just give a GitHub link. So imagine I have developed a model 4 years ago, and which is stored in this GitHub link. This should run seamlessly without any trouble in production. So what I'll do is I'll write my code, I'll push it to my GitHub. Nothing fancy, no best practices, no nothing. As I just want to run, no nothing like that. I just want to run a simple code which I have written in production. All I have to do is I just have to give this command to a DevOps engineer, or to a Linux guy, or to a MLOps engineer. So all he has to do is he just have to go and then run it. So I'll just show you what I'm trying to say. So that's all. I just have to run. So what this code does is, imagine that this what this line does is automatically it will create its own version of virtual environment. If you don't want to have your own version of if you don't want to create a, each time when you run you don't want to create a version, so you can give the version. Let's say you have already a virtual environment created at some place. You can give that version that you don't want to create. Each time when you run this command, you don't want to create that environment, you can give the version, what version you want to run. Automatically it will take care. So see, this is the command. What it has done is it has ran the code and everything is fine. So I mean, I can just go here. I can just go here and then see that run. It see that run here, 33 seconds ago. The model, and I can also see, this. I can also see the GitHub repository. This is running in my local laptop. What is the source of that code? Who ran? What are the parameters? Which model is good? And then I can also give and see the record, all of the information. I can see the metrics. What metrics? What are the parameters it has used? Again, more. I can save these artifacts. Here it is saving in a local environment. I can also save this in a S3 bucket. I can also save this in a Google Cloud, or maybe Azure Cloud, Azure Blob. So, or maybe Hadoop environment. So this is saving in a local environment. So this is the beauty. So the code which is developed 4 years ago, I want to run that. And imagine this 4 years ago, the code was developed. I may not have those dependencies in my laptop. So what it has done, it has automatically created created some of the environment based on based on the based on the based on the versions are mentioned which are mentioned here in this code. Where should I see that? You can just go and see here, right? If you go to the regression model, the run one which we ran, regression model, you can see uh, the versions, what versions, numpy, pandas, and all. I want to install all of these libraries. I want to run this. This is the project structure you need to follow, the entry point and all. This is a project structure, and this is the code. That's all. It's a simple code, same as this. Extra thing is this. This is the line, extra line. This is the extra line. And then yeah, this is not extra line. This is the extra line, and these are the extra lines. That's all. So with this, I mean, even if you don't want to store any of the parameters, only line which you require is this. Only this line can help you to build API, can rescue in version conflicts, can rescue in scaling, can rescue in many other ways which we face in a production, right? So that's all. So this the code which I developed 4 years ago, I was able to run. I was able to see. I can change the parameters. I can change and then run. Maybe 8. I'll rerun again, and then it will come. Alpha as a 0.8. So and if you see this, if the environment is already there, if you want to create a new environment, you can create. If the environment is already there, we can we can have that environment. So just give me a minute. It will show you here with the 0.8, right? Yep, this is the 0.8 alpha, and I want to compare these two models. Which model is I ran 24 seconds ago and then 3 minutes ago? I want to know which model is better. I want to compare side by side. Which model, which metrics are better? I want to go maybe r squared, which is, yeah, maybe this or this, whichever is better. I can choose the model, and then there will be model ID, run ID, all of the information. I can easily choose whichever the model I want to. So it's a savior. And if I want to make a prediction using pandas, I have the commands. If I want to make a predictions using Apache Spark, I have the commands. So it's very, very simple, and then easy to help, easy to compare. I can compare results. I can do many things. Like it also shows the source, who ran, where is the data source, code source, everything. It's easier. And then yeah, so there you can also run like this. GitHub URL GitHub URL, serving a model. You can say the most of the things what I've talked, right? I've covered here. Yeah. So in short, if you want to, how does MLflow help? If you want to, if you want me to summarize, so most of the time what happens is you develop everything in notebook, but you have no idea how to scale, how to write an API, how to integrate in some with some other frameworks. MLflow can rescue you with only simple command. You can write an API. It will create an API for you, application programming interface. All you have to do is do some sort of pre-processing and then call that API, and then it works seamlessly. If you want to have a batch prediction using pandas, you can do that. If you want to integrate, you want to have a cross functionality, right? You develop something in R but you want to use in Python, or you develop using Python, you want to use R. So companies like us, companies like Genpact, so we work for various clients. So in that pursuit, what happens is, we have a skills. We of course have to have a skills, with diverse skills, but most of the time we develop everything in Python. But sometimes client uses R, sometimes client uses Java, sometimes client uses Scala, any other. So if you see here, everything is there here. If you have a Java, you can import with Java. If you have R, everything is here. REST is there. So it's a cross and the documentation is very good. You can follow along, and quick start tutorials and tracking point. You want to integrate with SageMaker, you want to build pipelines, you want to run on Kubernetes, anything. And most of the things which we do, you don't have to reinvent the wheel. Simple terms, frameworks like this can save your months of effort, and they are very mature. And it, like, imagine 4 years it is being used, and it is very mature. And then if you are stuck anywhere, if you are facing any issues, community will help you. Feel free to go and start leveraging it, and then start leveraging the MLflow, and then you will see the actual usage of. I mean, you developed a machine learning model which is giving a super awesome accuracy, but if it is not in used in production, if it is not giving you the real value, what's the use of that model, right? If that is not giving you real value because you are lacking a production skills, or you are lacking the skills which you are not able to take it to production, then what's the use of that model? If it is not able to, if it is not going to production because of some financial factors or because of some politics, that's a different story. But if that notebook is not going to production, and if the real value of that is not getting used, then it's of no use. Start using frameworks like MLflow, Kubeflow, and then Uber has its own framework, Meta has its own, Google has its own. So, but MLflow is a very simple one. It's built in Python, and then it is being widely used, and most of the people use Python, and most of the people, they develop APIs, right? So from the scratch, you don't have to do that. MLflow can rescue you. Most of the people save their model as a pickle file and then use in Spark. You don't have to do that. MLflow can rescue you automatically. You can build a model. It's a central model. It can be consumed by various platforms. So that's all I just want to say. And apart from this, yeah. So, and there are a few other things I just want to tell. Okay, let me just yeah. So official document is very mature, and then it has, as I told, there are 4 things. Model registry is a new one. So tracking, we already know how to track. We projects, packaging a project. Tracking is what this is all about, right? You track all of the information. You track at a particular server, right? You track all of your experiment. This is the tracking. And then projects, it automatically help you with the project. This is the project. It will give you the structure which you need. This is the project. And then models, deploy models and diverse platform. This is the model. With one command, guys, just with the one command, you save your pickle file, and then you can integrate wherever you want. You can integrate with Spark, you can write an API. That's all. So this is what it is. This is again new introduced, so you can save, store, manage again models like in a center repository. people use this, or people sometimes they use some other platforms, but most of the things people use and tracking and models. So projects automatically get created. So this is what I just want to say. And then it is being used integrated with all of these frameworks. See, if you see here, most of the frameworks which we use in Java, most of them in machine learning, right? It has easily integration, and then you can cross from H2O to Spark. You can do from Python to Spark, Spark to R. So you can across platform you can use, and then it is being widely used by most of the organization, including us. If you see here, our name is also here, Genpact. And then yeah, so it is used by at a scale. Yeah, just wanted to tell, you start using it, start leveraging it, learn some of these practices, data engineering practices and all. You don't have to learn from scratch, but some of these skills will help you. How this has created a framework. Official document is very mature, so you can start using and start applying on your data set. The document is very mature. You'll get a lot of tutorials. There are books, there are courses available on this MLflow. This is the official document. I would suggest you also go through the Databricks managed MLflow. This is the paid manage MLflow. If you have a licensed Databricks, start using this. You don't have to write anything from scratch. Everything is there. In one clicks, you get all of these facilities with few commands, few lines of code. You can see, as you can see here, you can store it in S3. You can store it in Azure Blob, Google Storage, Google Cloud Storage, FTP server, any SFTP server. So anywhere you can store. I'm sorry, the Metastore, the artifacts as in all of these information, all of them, and you can run this in any Linux server with hosting this tracking part, and then that server is linked to this artifact, and then you can see all of those modules, all of those runs, in the tracking server. So this is what I just want to tell. So if you have any questions, I'll be more than happy to take. Start using, you'll understand the power of MLflow. I think quite a bit, but yeah.
Thanks a lot, Ladle, for that elaborate session. There are a few questions that I want to pick on LinkedIn, so let me just go there. So one question that Yogesh has asked, I'll pick that one first. So does MLflow support PyTorch BERT pre-trained models in Azure?
Yeah, it does.
Okay,
It's like a
okay.
BERT is like a NLP model, right? So you can use that. Yeah, it does.
And the documentation and all is properly given?
Yeah, everything is there. Documentation is there. Some of the functionalities I may not know, but yeah, so you can documentation is what are the various formats, storage. Documentation is very mature. You can start using. You'll get to know. Yeah.
And does MLflow also have a proper community where people can ask questions and
Yeah,
it is answered?
true. Yep, it does,
Yeah.
it does. Yeah.
Okay, awesome. Next question that I want to pick is by Milan. That he asks, in practice, how is MLflow different from Kubeflow for model deployment?
See, Qflow. See, we also have Qflow in our Genpact. Qflow is more of a Google, right? Google and runs seamlessly on Kubernetes.
Hmm.
So this MLflow is a simple Python library. It Qflow is I'm sure most of the people, many people use, and it is at a scale. It is more of a drag and drop. Various functionalities are there, but what I would suggest is, if you are using for experiment purpose, tracking all your APIs, tracking all your experiments, and then don't want to write API, and then in fact you can run the MLflow on Kubernetes as well. So Qflow more of a aligned towards Kubernetes, but MLflow is a platform independent. You can run on Kubernetes also. You can run on some other platforms. You can integrate with SageMakers. You can integrate with some other platforms where you can scale in less time. But Qflow is see, again, Qflow is developed by Google, so it was their internal project in doing similar in orchestration this ML pipeline. Meta has their own similar version of MLflow, and Uber has their own similar version of MLflow. And they developed based on for their internal projects, right? For their scalability of their internal projects, but they made it open source so that we can use. I would suggest it all depends on if you are on GCP, and if you have all your runs on GCP environment, machine learning, you go with Qflow, no doubt about it. But if you are new to machine learning, new to deploying your machine learning in production, and you're not using any of this, although you might be using it, but Google Cloud, but still you want to use, or you have a Spark environment and you want to convert into TensorFlow or some other platform, please feel free to use. There is no straightforward answer, but yeah, so people use both. But
Yeah.
Qflow is top notch on Google, not on other platforms. Yeah, yeah,
Yep. Okay. And technically, both are open source, also, right? I think
yeah.
that.
Both are open source, and yeah, you can feel free to. And both have a very strong community. In fact, Qflow is older than MLflow. Qflow, yeah, as I told, like, this is what these are all motivated, right? From the Qflow, MLflow is more. It was a motivation. Like Spark is been developed by looking at scikit-learn libraries, pipeline, and all. Most of the things are they're developed using by looking at the scikit-learn. So this was developed within Databricks, and then they made it open source. Yeah,
Okay. Okay.
yeah.
There is one question that Alan has asked: can MLflow be used for model monitoring also, basically by sending results on MLflow server when an inference is made by the model?
So you can get the inferences, but most of the times graph analysis doesn't support integrate with ZenML and other tools. But as say monitoring by default, it doesn't support. But you have to use some of the customization, or maybe write your own API to do that monitoring. Or it's like a execution, or by default it doesn't support. Yeah.
Yeah. Okay. Okay. Well, I think we are towards the end of the session. We don't have any other, question from the community. So I would say, I mean, this is where I say thank you to the community members for joining in and watching the session live or recorded. And thanks a ton, Ladley, for being so much available for the community and coming forward, preparing these elaborate sessions for the people to learn. Yeah. So thanks a lot, Ladley. It was a pleasure hosting you again. I think my net is flew.
For experience. No problem. Thank you again.
Okay, I'm not sure what's happening to the session because my internet is probably gone. Let me just check what's happening. Not quite sure. Okay, I think we're towards the end of the session. Um, Probably my internet dropped off and the session ended. I do not know. But if you're there, thanks a ton for being with us today. Keep on learning. Every weekend we'll have some of the other session. Next weekend also we are learning live. So make sure to join us at the same time. We'll be there across platforms. You can join on the same platform on which you're joining right now. We'll be there too. And also, we are starting off with two new boot camps in a very short while, and you can find them on DeFi. These are around data engineering and ML ops. So if these fields interest you, make sure to visit dphi.tech, that's defi.tech backslash bootcamps. That's where you will find all the information. We look forward to seeing you again. Have a great day or evening ahead. Bye.